This is the OpenHBI course Linked Data Engineering, Lecture 1, Linked Data and the Web of Data. In this section of the lecture, we want to talk about the Semantic Web Technology stack. So let's first have a look at this interesting and huge stack of technologies which are all enabled in the semantic web and of which linked data actually is a part of. And with a part of technologies or some of these technologies, we will deal in the course of this course, of course. So let's try to start at the bottom. In the Semantic Web Technology stack, the basis or the foundation is the usual web platform that you know. So we have, for example, for identification, the concept of URIs, of Uniform Resource Identifiers. In the international form, these are IRIs, which means then International Resource Identifiers. All things I want to talk about, I express or I identify and reference with the help of a URI. And the information I put into messages and the messages that are exchanged, they are exchanged with the help of web protocols. So then, for example, with the HTTP protocol, the Hypertext Transfer Protocol. And encoded are these messages usually with Unicode, so with a simple coding standard. And I can also use all the available authorization methods and technologies that are available on the web. So this is the web foundation of the Semantic Web Technology stack. Now you might ask, where do the URIs come from that we use most times here also in the course? So the DBpedia, where does the DBpedia come from? I already told you that in the DBpedia, the knowledge that is available in Wikipedia is put and then expressed in terms of RDF. It's not all the knowledge that is in Wikipedia. Wikipedia contains more, but probably you have seen that for most of the articles on the right side, you have a small window, a small table in which structured information somehow is aggregated. So, for example, here on the Wikipedia page for the planet Pluto, you have this nice little info box on the right side, where you will find not only a picture of Pluto, but also a table with structured data. And of course, this structured data can easily transferred into an RDF representation, which then in the end makes up DBpedia. So this is the way how DBpedia is created, and then you can dereference DBpedia and you will get, for example, in a web browser, human readable information, a web page which is created from the data which is in DBpedia, but you can also access pure RDF representation and access this data with the help of a machine and not with your browser. This brings us to the information exchange layer. This is the blue layer, the third layer here in the semantic web layer cake. So why have we skipped the second layer, the green layer? The green layer only are several serialization formats of this information exchange model that we use. So RDF can be serialized in different formats. And these different formats, they are in the second layer. There you have, for example, an XML representation, a turtle representation, and much more. And usually the model which is behind that is RDF. So this is the blue layer. We have already talked about RDF. We will go back to that also in more detail later. But the point is, RDF is encoded in triples. So it's a triple-based model. All information is expressed as a subject, which has a property, and the property usually is assigned a value. So then the value will be the RDF object. So always subject, property, object constitutes an RDF triple, and all the knowledge or all the facts that you see here in the gray box, this is expressed in RDF in a specialized serialization. Here it is turtle serialization, which I will explain shortly later. So this is RDF. The point then is, where do the structures that I make use of in RDF come from? There I am now on the fourth layer, where we can build models. And models, for example, can be built with the help of so-called RDFS, which is RDF schema. And here, for example, you can define new classes, you can define new properties, you can define restrictions on properties and stuff like that. So this is a kind of schema language which is used to create classes, to create relations between classes and stuff like that. And then you can, for example, express simple facts like that. For example, that you say the class planet is a subclass of celestial body, and the class planet usually has a discoverer, which is a person. So this is simple knowledge which can be expressed with the help of RDFS. But there are also other vocabularies, other languages on that layer. One of the other languages is OWL, which is the web ontology language, so which we will only look very, very briefly, because this course will be mostly about how to apply linked data technology. So what I can express in OWL is, for example, I can define more elaborated, more complicated, more expressive logical constraints. I can define two new classes. For example, I define a class living people and a class dead people. Both are subclasses of person. And then I can say, okay, no living people is in the class of dead people. So these two classes somehow must be or should be disjunctive. And I can express this with the help of the OWL description logics language. And moreover, what I can do, I can use, for example, also rules. So this is also on the fourth layer. It's in green, a little bit below here. You have rules with RIF. And this is the rule interchange format. There you can define logical rules which express even more knowledge. Here, for example, you have a simple example for you say everybody or every person who had the death date should be in the class dead people. So read it. It's written here in first order logic. It says for all x, where x is a person, and there exists a y, and y is a date. And for both of them holds that x has a death date, then x is member of the class dead people. So this would be the literal translation of exactly this first order logic rule, which means that every person who has a death date is a dead people. Okay, so this is even more expressive, and we will only look at that on the side. So this is the logic level, even more complicated. What is more interesting for us is if we want to access available linked data on the web, we need something like a query language to make easy access available for this data, and also to aggregate the data, to filter the data, and also to make sophisticated queries on this data. So for this, we have the so-called Sparkle, which is a query language for RDF and or RDF-based data, and this is based on the query language SQL, which you might know from databases. So it's a rather easy language, and everybody who knows SQL will also be able to learn Sparkle, which of course is also part of our lecture. And you see here a small Sparkle query which tries to look for all space missions in the solar system which have become a satellite of their target. You don't have to understand the Sparkle query now. We will get into that later on. But if you try to execute this query, then you will end up with a table where you have all the results and see all the space missions and also all the targets of these space missions, so of which they have become a satellite. So we have also a link here, over there. Try Sparkle query at public DBpedia Sparkle endpoint. So if you click on that, you will transfer to a public DBpedia Sparkle endpoint. We can try this out. So here you see you are at a public Sparkle endpoint. It's Virtuoso Sparkle Query Editor. We are here on the DBpedia endpoint. This is the query. This has been automatically transferred here into this window. And then you simply say run query. And then you will see here the result, which is then the table of all these space probes you have here and all the celestial bodies of which these space probes now are some satellite of. Okay, so these are the building blocks of the semantic web, of which linked data is a significant part of. And in the next part of the lecture, we want to focus on linked data explicitly and how to make linked data.